Okay, I see. Okay. That's a nice room.
Okay. Tu diffuses tu broadcast là? Okay. Good morning, everyone, both in the room and online. We'll be beginning this session very shortly about IFC research programs. And the first presentation will be done by Mr. Chi Zhang from Aptech about IFC Rail in a nutshell. Up to you, Chi.
Okay, thank you, Siva. Could you hear me?
Yes.
Okay, thank you. So, good morning, everyone. So, welcome to my presentation. My name is Chi Zhang. I work in Aptech GmbH. So we are a Swiss company, and we take charge of the project and management of building smart IC rail project. And my personal role in this project is the technical lead of this project. So in this presentation, I will give you an overview of IC rail, and it's titled as IC rail in a nutshell: requirement, standard, and implementation. So let's start. Okay. So when I proposed the title of this presentation, I've been keeping asking myself, so how should I present this project? Because it's a very large project. It has 4 years time and 10 nations and more than 200 people involved, and thousands of pages of documents produced. So yeah, it is quite challenging work to present this project in 20 minutes time. But I try to do my best and to, let's say, to pick up the most essential part of the project. So at first, the background of the project. So IC Rail project is in a bigger context. So this context is IC is being expanded from building to infrastructure domains. So this work was initiated in 2014, and IC Rail takes charge of the railway part. As you can see from the timeline, it starts from beginning of 2018 till now. So it has been there for 4 years. It has 2 phases. So in the first phase, we focus on requirement and standard, and in the second phase, we focus on implementation of the standard. So IC Rail project is supported by these national railway and infrastructure companies, as you can see all these logos here, from 8 European countries and China. Yeah, this is how this project was started at the very beginning and how continued till now. So instead of talking about how this project is organized, in this presentation, I would want to focus on what this project has done. So I think I can present this part in 3 aspects. So requirement, standard, and implementation. So these 3 parts are interrelated. So we need to have a requirement, then we can make the standard, and we have a standard, we can implement the standard and then validate the requirement. So they have like affect each other. So, but these are the 2 key aspects of this project. So the first part, the requirement. So it is about all this. So we would like to digitalize the railway. So as you can see, railway is a very comprehensive domain. It has many subdomains like signaling, telecom, track. It has many types of elements. It also interacts with other domains, like in the level crossing case, it has some interface with a road, and it also has interface with tunnel. It's also related to bridge. So it is a very comprehensive topic that we are trying to bring all things together. So more specifically, regarding domains we focus on in the railway, we have 4 major domains we focus on. They are track, the energy, signaling, and telecommunication. And on top of that, all as a foundation of all these 4 domains, we also have this, we call it the common schema and shared elements. So this part will focus on all these common things shared between these 4 domains, including things like alignment, which is an essential concept in linear infrastructure, and like the linear referencing concept, and some common elements like cables, ducts, and drainage systems. And we also have this spatial structure concept, which defines how this model, how the digital BIM model can be broken down. So these are the things that we focus on to define the requirements. And we have another aspect of requirements, which is the process and use cases. So these are the things we also try to do. So we made, let's say, a reference process map. By the way, this is very small. They are not supposed for you to read. We have some links shared at the end of this slide, and if you are interested, you can check the big diagram of this. And based on this process map, we have like 38 use cases defined, and based on the use cases, we'll also define exchanges, because IC, that's the, let's say, the major task that IC could do. So IC takes charge of exchanges between software, right? So this is another aspect that we focus to define the requirements. And on top of that, we also make a conceptual model. So this conceptual model is a UML model. It is defined independent with IC. So it is mostly trying to formalize the business requirements. And so how, which means how this, what are the elements in the railway domain, how the elements how elements can be put together to compose things, and what are the properties of these elements. So in total, we have like more than 600 classes defined and thousands of properties. So covering, if we subdivide them into domains, these are the numbers that you can see that to define this conceptual model. So all this part is like defined in the IC Rail phase 1. All these things are done in the IC Rail phase 1. And so we have these deliverables for this work. We have this requirement analysis report, another requirement report, and conceptual model report defined. So these are the things that how we define the requirements and how we formalize the requirements. And the second part of IC Rail project is the standard. So once we have a requirement, we need to put this requirement, embed this requirement into IC to make it to make these requirements, let's say, implementable by software vendors. So this is the IC Rail input in IC 4.3. So so in the left part, you can see this architecture of IC 4.3. Based on IC 4, it has added some more subschema, and it has 4 layers, and we have actually given input to all these 4 layers. So for the resource layer, we have defined the alignment, linear placement, and sweeping geometry. And for this core layer, we added the spatial structure concepts. And in the shared layer, we also have this cabling and drainage. And in this domain layer, we have more railway specific elements defined. So this is a, let's say, a high-level overview of the input of IC Rail into IC 4.3. So I would now talk about some key concepts, let's say the key contribution of IC Rail project to the IC standard. So the first thing is the alignment with client. So as you know that alignment is like a very essential concept in linear infrastructure domains. And in the railway specifically, we also have this client concept, which means it's kind of the lateral inclination of the track for kinematic purposes. So in this alignment model, we have defined this alignment. Well, this is of course based on this IC alignment project, which was done before in 2015. So based on that, this alignment can be broken down into 3 layouts. This is a more traditional way how to represent alignment. We also define the geometric representation for alignment. And more specifically, we have defined a very comprehensive types of transition curves. This is probably the most complete set of transition curve types in all the open data models in the world. So it covers all these kind of different transition curve types. It could probably covers, I could not say 100%, but 99% of the cases in the world. And the second essential concept is this linear placement. So linear placement is because we are doing 3D, right? So we're doing 3D model. So in the 3D model, the most, let's say, important thing is how we define the coordinate system, how we can put 3D objects together into the coordinate system. So for the linear placement part, this is also very much related to all these linear infrastructure domains. It's like the placement by distance along, alignment, and offsets. And for railway, we specifically consider the requirements of this offset and orientation, considering kind. So this will be useful for elements like sleeper and fastener, all these things that are closely related to inclination of the track. And the other thing is that we defined this concept of managing stationing for linear assets. So this is specifically useful for asset management. And so this stationing, we have different ways to define stationing based on mileage or based on kilometer. This all depends on the specific requirements in your country or in your project. And the other thing is this parametric geometry that's specifically useful for railway. And it's called like SWEP area solid. This is about creating the shape of the object by sweeping profiles along alignment. So this would specifically be useful for things like the rail, the geometry of the rail, for the ballast bed, for the pavement, for the platform. So all the things that have the geometry that can be created like this. So yeah, so this parametric geometry is always kind of like a debate how complex geometry can be, but parametric geometry at least provides some options for software vendors to implement in order to make, let's say, editable geometry after exchange of the bin model. And it also would be useful for things like a quantity takeoff. For all these things, it will be easier for further computation. And the other also, this is another important concept, is the spatial structure. So it defines how a beam model, how a railway beam model to be broken down. So this defines, well, this is just one example. So we could break down the railway project using this lateral or vertical way. So define this railway into this track structure, superstructure, line side structure, and this railway substructure. So this would also be useful how we manage the data. So into different subparts. So what about semantics? So all the other things, all the things that I presented before are the things about structure or the foundation of the model, but we also need semantics, right? So we need to define what type the element is and what kind of properties this element can have. So in this part, we focus on these 4 domains that we define all these kind of either define this semantics based on existing IFC entities or existing predefined types in IFC, or we extend entities or extend the predefined types into IFC. So all the things related to 45 entities and more than 200 predefined types in the IFC 4.3. And we also have more than 500 properties grouped into more than 100 property sets. So yeah, so this is just a snippet of all the properties. Yeah, this is about this signal. And we have, of course, I cannot show all these properties, but you can find all the links at the end of the slide. So as a summary, so what it can do, this standard can do. So So these are the basic information that we can put into IFC. So basically how the railway alignment is defined, how the element is placed along alignment, and what is the mileage, what is the type of element, how the element is decomposed or aggregated, and how the geometry of the element is, and what is the function this element performs, and what is the network between elements, and how the asset is managed, and what are the properties of elements. So this is basically what kind of information that can be put in the IFC, and more importantly, what kind of information are standardized into IFC from IFC Real Project. So the third part is about implementation. So we have the standard, we need to test it together with software vendors to implement it and then validate the standard. Right? So this is mostly done in the phase 2 of IFC Rail project. So in order to do that, we made an IFC Rail organized IFC Rail Implementer Forum. So this IFC Rail Implementers Forum involves 16 countries. So we basically organize all our domain experts from stakeholders together with software vendors. So they come from 16 countries and 10 stakeholders, 28 software vendors, and we also have these IFC technical experts who support domain experts to formalize the requirements, also support software vendors to implement IFC. So that's the participation. And regarding the process, we also define a kind of like a two-stage approach. So at the first, we focus on the unit test. So unit test is kind of like focusing on a very atomic concept, just like the concept that I presented before, like focusing on alignment, focusing on linear placement to do some small tests with software vendors. And then later we also define storylines. So the storylines are much more comprehensive cases based on realistic project requirements. It has a process, it has information from multiple domains in order to put all of things together to see how the model can be made. And during this process, it's not like we just ask software vendors to implement, because it's a testing process. So once we ask the software vendors to implement for some runs, we will get some feedback from them. We will also get some feedback from our domain experts. Then we update the standard. So it has several runs from IFC 4.3 RC1, which is the beginning of this phase, until IFC 4.3 RC4. So this is the work jointly done between IFC Rail project and the Infraroom project. It's a very smart Infraroom project, because IFC 4.3 is not just a rail, it also has a road, has a bridge, has also a waterway, all the other infra projects. So we do all the things together. So for these storylines, we have very diverse storylines defined by domain experts from our stakeholders. We have very, very detailed, very focused storylines like camping machine, like track renewal, that's just a focus on a specific small case. We also have quite a comprehensive one like acquisition and upgrade of existing railway line or new high-speed line from China. And also has urban railway infrastructure integration from France. This is also very focused, let's say, telecommunication domain focused, this ERTMS system. So we have quite diverse storylines. I guess from previous sessions yesterday or today, we already have some stakeholders presented the result of their storylines. So yeah, you can refer to more detailed information to these presentations. So as a result, we a lot of software vendors contributed to this work. So these are the screenshots provided by them. You can see we have big vendors, very traditional BIM big vendors, Autodesk, Dassault Systems, Bentley, let's say, railway-focused medium and small vendors like Rail Complete. We also have ACA who very actively ACA and Geodesire and also 12D very actively contributed to this project and produced many IC files. And we also have kind of let's say, checking between software vendors. So some software vendors produce files, and these files will be imported by some other software vendors to see whether the files are created correctly or the files are implemented. The IC standard is implemented correctly, and we thank to all these contributions from these vendors. So as let's see some statistics about the results that are produced in the Rail project. So in the unit test phase, we in total have 130 IC reference files produced, and these files are already published. And in the storyline phase, we have 138 IC files produced by software vendors, and it covers 82% of the concepts focused by IC Rail project. So the coverage of the tests are I would not say totally complete, but covers the most important part of the IC Rail project. So in total, more than 260 IC 4.3 files are provided during this testing and implementation phase. And we also defined a kind of framework to how to check the IC files. So how to validate the standard and how to validate the implementation. So in this, let's say, in this early stage of implementation, we have to rely on many tools. And IC checking, IC model checking is always a complex topic that usually we cannot rely on one tool or one platform to do this work. So we have to rely on many different tools which focus on different aspects of the checking. So, for the schema parts, we rely on this KIT IC checking tool. So this basically checking the schema compliance and some essential parts of the IC file. And then regarding the content, for the semantics, we rely on this Regular and this Beam checker. It's called Beam Tester Plus. It's based on IC OpenShell. It's an open source library that can check this semantic part of the IC file. So we kind of coded some rules based on this library. It's also supported by Regular very much. And and for the geometry checking, this RDF software also supported a lot to define the geometry checking for this alignment part. And we also have this IST, which kind of more like a semi-automatic checking tool that convert IC files into Excel sheet, so then domain experts can more easily browse the IC files based on Excel sheet to see whether things are done or not. And of course, we also have to rely on some viewers to manually check the IC file to see whether things are visualized correctly and whether information are done correctly. So it's quite a comprehensive process. Also, different people focus on different tools to check the IC files. So all the published deliverables and all this information about current deliverables from ICRail have already been published, and we have a website supported by Smart. So it has all the public information, all the deliverables till now published in this website. So you can check all the details about these deliverables. And so the ongoing work and the future work, So the first thing is that from IC Rail perspective, is like we would, yeah, this is definitely led by Good Smart. It's like as an important part of IC 4.3. So IC 4.3 will be delivered to ISO to be in ISO standard. This will be a process. This will require a procedure, but this work is already initiated and will be delivered to ISO this year, very soon. And the other thing is about MED and certification based on IC 4.3. This is the work between IC Rail and Unismart Infra Room project. We together define MED. So it's a subset of IC 4.3. This is specifically used for software vendors to do the certification. So these are the two things which are ongoing, and yeah, and will be done. Okay, so thank you. So this is my report about IC Rail. So thank you very much.
Thank you, Chief, for this presentation. Before we take any questions from the room, from the online audience, maybe there are some questions in the room. Maybe not. Maybe Frédéric, can you check if there are questions from the online audience?
Yes, I don't have any questions in the chat right now.
Okay. And what about you?
Oh, yes, of course I have some. You've been talking about more than 500 new properties in 100 property sets, if I remember well,
Yeah.
the slide. My question is, will all those properties added to the IFC schema, or do you plan to use some tools like BSD to handle those properties? What is the plan regarding that?
Both. So it is being added. We still have a few pieces need to be done, and I think we still have 8 pieces open, and so it will be done very soon in 1 or 2 weeks time, and then they will be in IFC specification, and then we should also put into BSD.
Thank you.
Well, I have a question myself, actually. You well explained the multiple domains involved in IFC Rail. Even if we talk about rails, roads, bridges, tunnels are involved. And another area where this multiple domain is also present is the forthcoming IFC tunnel. I don't want to step on the next presentation, but do you think the way we worked in IFC Rail, linking the different groups thanks to the technical services, could be helpful to other domains like IFC tunnels, and I'm thinking of geotechnics, for example. Both domains need to be harmonized, coordinated, and we do have some experience with the harmonization between rail and infra. So what would be your best practices, advices, or your experience with this?
Yes, just from technical point of view, I would say definitely yes. I think we definitely need harmonization and work together and close communication. This is also based on experience with infra room projects. In the phase 1, we had harmonization work with IC Road project and IC Post and Waterway project. And in the phase 2, we actually even much more closely collaborated with infra deployment project. So a lot of agreements are done together in a very close and intensive meetings between technical service of 2 projects. So for the tunnel project, it's also a very essential part of railway. So that, yeah, from technical point of view, definitely yes. I think it will be very useful if we can have some regular meeting, and then for some key topics like if alignment or geometry or some spatial structure concept, this require intensive discussion.
Okay, thank you. Time for us to switch to the second presentation. I would like to make sure that Mr. Costamo is in this room. Please come. The second presentation is titled IFC Airports, Extending the Use of Open BIM in Airports. Yeah, exactly. Up to you.
So, thank you very much for the introduction. As said, the topic of for my presentation today is the IFC airport. I will briefly tell a bit about the airport room because it might not be familiar to all of you. And then actually I have to thank my colleagues in the room, in the steering committee, Ariska Krug and Maya Trifona, who are actually the leaders of the IFC airport project. Unfortunately, they were not able to come here in person, but their input on the project has been very valuable. And they have been leading the development for the last 2 years. So my role is here more to present the progress and the current status, not actually show this as my work. It's the work of Ariska, Maya, and the rest of the team. But we'll go more into that during the presentation. So who am I? I'm one of the 2 co-chairs of the Building Smart International Airport Room. Another co-chair is Adam Rendek. He's in San Francisco. I'm stationed in Helsinki in Finland. And then the rest of the group is more or less spread around the world. We have the furthest in the east is currently in Tokyo. And then we have very active participants in the project and also as external commentators from the US. So we're pretty spread and sometimes scheduling meetings might be a bit of a challenge because it might be a midnight for somebody and early morning for somebody else. Personally, I've been involved in the BIM standards and the IFC for a bit over 5 to 6 years, first in Finland and then for a couple of years in the international side as well. So what is the purpose of the airport room? The airports themselves are ecosystems. They're huge, complex entities. That's an example of Changi Airport in Singapore. You might have a railroad, you might have a huge waterfall, you might have a forest in the middle of the airport. And in that sense, we're also combining a lot of the other rooms inputs in one building or multiple buildings in the airport. Airports are a combination of the other rooms' input, so we are not alone, we are not inventing stuff that others have already invented. There's buildings, construction, infrastructure, production, railways. Sometimes, quite often, railways are actually part of the airports. Sometimes they're managed by the rail authority, sometimes they're managed by the airport itself. Some airports, for example, have sky rails, railroads on top of buildings, and they are usually part of the airport, not the railroad authority itself. And we have a lot of technical stuff. Airports also have things which are not discussed or covered in other rooms. For example, the fueling systems, the jet bridges, all kind of passenger-related control, management, package handling aspects. So there's a lot of stuff that from the airport perspective is missing from the other rooms, but is very valuable for the airport and quite often key parts of the airport operations. As an example, the jet bridge, it's airports with 10 million or more passengers. If the jet bridge is missing from the BIM model, people in the airport are going through something that is not in the model. And that's a big issue, especially because airports are heavy users of GIS data, so location data. And we should link that to BIM models in the future better, but today there's some challenges because there's missing things between the 2 standards and quite often different ways of working in different airports. The airport room steering committee currently is presenting in these countries. As said, it's from all the way from Singapore and New Zealand to US, Europe, quite well presented, and the Chinese Civil Aviation Authority is also, Civil Aviation University has been also very active participant in our work. We also have an airport industry committee, which is free for all, so you don't need to be a part of the Building Smart either. So that's more open discussion forum. We're giving updates on what's been going on, what is the latest development, where we're heading to, and that's initiated some interesting discussion, especially in US where the airport room is just starting. So we have a lot of input from the airport authorities and airport owners, which are using BIM but are not part of the Building Smart community yet, so we can still get the input from them. But if we go to the actual airport entities project, in this aspect, as I said, Maya Trifona and Ariska Druk, they're both from Schiphol Airport in Netherlands. They're leading the project. They have been re-initiating it a couple of years ago, and they've been very active on leading the bi-weekly meetings of the project group so far. They're both working on asset management and data engineering in the Schiphol Airport. They do a lot of things with information management, and they're both specialists on GIS and BIM related topics. So you might have met them also in other meetings. Maya, for example, has been part of the Building Smart International technical definitions and things like that. The airport project, it's not clear. As said, the common industrial standard or common airport standard doesn't exist. Different airports, for example, use the different words for the jet bridge. It might be a gate, it might be a jet bridge, it might be something else. So there's not a common understanding in the industry, and the language varies between countries. So even in English-speaking countries, there might be a different term for this, exactly the same thing. Or the term might include more things in one country and less in another country. So that's one of the specific areas which kind of led to the start of the project, and the hope is to get a common understanding and agreement that what is included in the terms, and for the BIM model's sake, and especially if you want to make the models machine readable in the future, you need to have the same term. You can't change the term for every single BIM model. The airports have a lot of specific objects. As said, there's baggage handling system, there's passenger handling systems, gates, anti-return doors, jet bridges, de-icing systems. Probably doesn't exist anywhere else except airports. But if you think those systems are covering jumbo jets and big airplanes, there might be hundreds of, there might be actually tens of kilometers of pipelines underground because of those systems in an airport. And it's not visible to the surface, but it's core element of the airport operations and need to be working, because once we don't have de-icing, we don't have airplanes flying. So it's quite critical infrastructure from an airport perspective. Without clear definition, everybody uses a different name for the same thing. You can't compare two projects. If you hire a new subcontractor, they might define your jet bridge a bit different term, or use a capital letter instead of a small letter, and the end result is that you might have varying contents of different models, and they're not really comparable. One of the aspects of the airports is that they are not usually rebuilt as such from scratch. There are still some airports which are built to empty land and a full airport. But actually most airports have hundreds of smaller projects every year. So it's update here and there. You update the doorway there, you move the gates a bit further, you give more room, especially during the COVID. They had to reroute people so they don't pack up in the same places earlier. And all these small updates change the model content. So if you change the model content and you don't have a common agreement what should be in the model, you end up having a lot of variations from the data. The benefit of the project is that we would get a common understanding. We could have the same way of working, at least on the airports who agree to use the IFC airport, so the definitions. And then in the future, especially for the companies who are working with multiple airports or airports that have multiple subcontractors, it would make their life a bit easier. They could be working with different subcontractors, but still give the same requirements for the data. And they wouldn't have to guess again for the next project, okay, how it's defined here. It would be the same way of working. And in a sense, we would be speaking the same language between different airports. There are some issues on that. Some airports are very happy to open their practices, but of course they're all businesses, so some airports are very sensitive on the data. And being open or having a common standard doesn't mean that you open all the data to everybody. It's just the structure of the data should be commonly understood. The core working group currently in the airport project is Maya and Ariska from Schiphol, Carl from Auckland from New Zealand, and then we have Mike from NACO, which is a consultant and expert on airport BIM modeling, and Christoph from Vienna Airport, and that's the core group of the work currently. They're the ones having the most meetings on weekly or bi-weekly basis. But then we have input from more than 40 people on giving ideas that, okay, we have that, but we don't have that. Or we have this kind of radar system, it should be included in the entities. As said, the project, actually original idea of the project is more than 7 years old, but it kind of died out in the middle. And then it was restarted in 2020. It's almost 2 years ago. There are a lot of steps, but the first part of the project was figuring out where we are, what's missing, and what is being done by the others. So we don't want to have the same term in airport in a different way it would be in railroad. So in kind of one of the big aspects in the start was to map what is in IFC 4.3 and the revisions of that as well, and to build on that. So if there's something important waterways, which partially is the thing we have here, so we don't want to replace that, but we want to build on that. We might need to add a special property set that is in package handling system, but is not in a cargo handling system on a port, for example. We did a lot of that work actually in Airtable. We actually mapped all the airports. The main ones are there. There are 6 different classifications, 6 different, you might call them codes, because not all of those were BIM objects. They might be a CAD code for a radar or some kind of safety equipment. But we mapped all of those, and then we linked them to each other. So figuring out, okay, this is pretty much the same as this other one. They just used a different term for that. Or it might be that this is an additional feature of somebody has a radar and somebody defines as a specific type of radar, because airports have, as an example, they have different type of radar for figuring out what's in the air or what's in the runway. So they are using different systems and there are different level of definitions. And then we would use kind of a pretty simplified decision map. Is this something relevant? Is it already existing somewhere? Should we build a property set on that, or should we define a complete new entity? And in the end, we end up with this kind of a table where we kind of have the current definitions, what are extensions, what are completely new IFC entities as such. And then we also added pictures on those, because that helps understanding what it is. If it's a package handling system, okay, put the picture there. Somebody might call it a conveyor belt, but we still understand it's the same thing. And it helped a lot because the terminology is not standard and every country has a bit different way of talking about the same things. And then we tried to remove duplicates and map it to the IFC 4.3. So we would have the latest version of official IFC as starting point for the airport project. As an example, conveyor belt. That's a picture of that. There are some values on that. There's something existing in the IFC 4.3, which is already conveyor people or material moving conveyor belt, but it was missing some of the parts that we need on the baggage handling system. It was more focused on the cargo on ports and waterways. So there's additional features on that. We also did survey to the matter experts, so we consulted also external people, not just the people in Building Smart, to get the comments on, is this relevant? Is this something that should be there? Is there certain properties that are by law or by local requirements linked to this entity? And that kind of work, it took quite a lot of time, but it was very valuable in the end. And for the survey example, this would be a package conveyor, there would be an email sent to experts, and then there would be comments, is this something you use? Is this something you might use? Is there something missing here, or you think this is completely okay, this is how it should be in the future? In workflow ways, there was, of course, having stuff on Airtable or Excel was the starting point. Then we did definition of some examples on JSON as well, and to figure out how to get it on the Building Smart Data Dictionary. Currently, we are in a stage between the actual classifications in data dictionary, and we did already proof of concept on that on 4 entities. And those 4 entities are here. So if you go to Building Smart Data Dictionary, put there search IFC airport, you might come with these 4 objects. There's anti-return gate, automated border control reader, approach light mast, and check-in conveyor. So this was our proof of concept. It works, it can be done. And in the future, this pilot will be the basis for the actual creation of the IFC airport entities. Originally, we had an idea that we will, let's say, create a completely new IFC revision. That might happen in some revision, let's say 5 point something or 4 point something, whatever comes after 4.3. But currently the idea is that the easiest way to give people access to these entities would be this data dictionary. So we could publish them there. You don't have to use them, but they're available there. So if you want to use them in your project, you could download them as one package for the airport project and then utilize them for the purposes you need. There's of course different design offices. If somebody's designing a package handling system, they're not really interested on the light masts on the runway and the other way around. So there you might use some of them or not use any of them. But as said, you can find some of them already in the Building Smart Data Dictionary. And if somebody wants to see it, you just write it down there. And then you come up with the IFC Airport 1.0. As said, this is a proof of concept stage. It's not the complete list of entities. But you can already see what is there. And from our technical purpose side, there will be more things added here. And most of the work in the project so far has been done on the, let's say, the in-kind contributions. So it means that there's been a lot of unpaid work here. That has a bit slowed down our progress as well. And taking the current situation in the economy, we can guess that airports are pretty much affected all around the world. So there's been a bit of a slowdown on the progress, but otherwise it's been moving quite nicely. Taking that with a lot smaller budget than the railway, we're already able to define over 100 entities. And I think for the latest version or the idea what we would add in the IFC airport entities was 97 new entities with properties. And as said, we have to thank the in-kind contribution from the participants in the project. And ETS from Italy has also been willing to support us on the financial side because there's document creation and all kind of things that also require financial contributions. But that's in short the update. If somebody's interested, there were a couple of emails there, for example, for the airport industry forum. Laura Tan is a right contact, or then go through the contacts of Building Smart, say I'm interested, let me know. And they will probably forward the emails to me or Adam, and then we can get back to you and discuss more on the topic. But that was it in short. Thank you.
Thank you very much. Again,
well-known softwares in the industry. There's not really too many airport-specific softwares. So in a way, if we are able to get the general link between the BSDD and the software side, then we are able to use those entities and property sets without having to remodify the softwares themselves.
That's really good news. Thanks a lot.
Yep.
Thank you. update about IFC tunnel.
Yes, please. Just let me know when the slides are on screen. Maybe one word about myself. My name is Michel Rive. I'm running a company called Vianova France. We do BIM for infrastructure projects for 15 years now. We act in France, but we've been acting as well in Doha, for example, Qatar. We've been acting in Africa, like today in the metro of Abidjan. And we've been acting as well on the extension of the airport of Santiago de Chile. And at the time, we would have loved, to see this be ready, because we were really trying to optimize the process in terms of a global quality check for the infrastructure owner. One of the things that I'm doing right now is acting on behalf of Building Smart International as a project manager for the IFC tunnel project. And this project was started in June 2019. So it's 2 years old only, and we've been progressing, and I'm happy to report upon what we've achieved over the past last years with this one presentation. Just so you do understand, it's been said before, but what we have right now available at Building Smart International is IFC 4.3. That comprises everything related to alignment definition, DTMs, railways, roadways, port and waterways. And this is the basis upon which we are going to be extending this one existing schema with tunneling related extensions. And by tunneling extensions, I refer to geotechnics, everything that is related to the structural aspects, so excavation, support lining, and everything that is related to the systems that equip a tunnel. So our project covers those three main disciplines. Bottom line, everything, as you've understood from before, is going to be injected into the ISO certification process. And as of today, this is going to be complementing the ISO 16739, which, as a matter of fact, combines every production that is done on behalf of Building Smart International through the IFC. So this is very much the reference to international ISO norms that everyone should be aware of, and this comes in addition to the 1960 650, which relates more to the BIM management aspect of things. So these two set of norms, are key for people to understand they exist, and this is what we enrich moving forward. Just a word on the market. It's very dynamic, very demanding. It's a very complicated market, but you see projects of underground structures everywhere in the world. We are lucky, in a sense, to have a series of key projects here in Europe, but you see many others. Of course, the largest in Europe today is the one from the Société du Grand Paris, with 180 kilometers of tunnels, for those who wouldn't know. As I said before, we have projects everywhere, and we are lucky enough to be in a close collaboration with the International Tunneling Association, which is an industry association existing for a long time. And they've catched on they've caught the value of optimizing their processes globally through a BIM approach. And they have a working group on this matter, which act in a sense as a sort of a reviewer of what we do from an end user perspective, from an industry perspective. So this collaboration is really key to us. The project itself is today made of roughly 40 people, 45 people, coming from all over the world. And in terms of profiles, we have infrastructure owners, we have geotechnical engineers, we have system engineers, we have civil engineers, of course, national prescriptive agencies, bodies, and research bodies. In terms of geographical coverage, we have people from New Zealand, Australia, Japan, most of Europe. We are happy to see the representative of Brazil and the US joining us. The US market is, of course, rather key for Building Smart International, given the fact that many big software vendors are actually based out of the US. And Building Smart is making a big effort to make sure that all this standardization effort is being taken over by those actors that are based in the US, which was a bit of a difficulty in the past. These four teams, I mean, there's 40 people that are split in 4 teams, and I've just made a quick calculation. We progress at a pace where we roughly have something like probably 10 meetings a month, which altogether has led to probably an in-kind contribution to close to 1 million euros if you count the hours of those 40 people working on these 4 teams. We have 3 domain teams, geotechnics, structures, systems, and we have a technical team, and the technical team is the one that is taking over the industry requirements to implement them into the IFC mechanics. And we have, of course, a series of cross meetings between domain experts and IFC experts to make sure they understand each other. This is a very interesting point in time in the project where you get the 2 perspectives to try to match. The scope of the project we defined on the basis of a series of use cases, and those use cases we aim at basically describing the different steps of the development of a project for an infrastructure, an underground infrastructure, and that starts with the description of the existing configuration or lack of understanding of the configurations in questions, all the design phases, the simulations that have to be based upon data that is provided from the design, the tender processes, what do we carry, what do we provide through the tenders in terms of geotechnical models and civil engineering models, everything that is related to the tracking of the as-built, and then the handover to assets management and to GIS, as well as to anything that would aggregate the geotechnical configuration that have been encountered as the excavation was progressing. So we need to loop loop that loop. So to make sure that everything we discover, we reinforce during the process is being documented properly. So that basically helps us cover the scope, define the scope. The first phase of the project, which basically ended up autumn 2020, with the definition of the functional requirements, so the industry expectations, if you will. And basically discovered both the geopositioning geometries, soil and rock conditions, construction methods, and different systems, functional systems that serve the channel, and the use cases that I was referring to. We had a series of 3 experts meetings where we provided that information for review. So we had more than 100 people at each of these meetings. And from that basis, the expert team, the IC expert team, started to develop specifications for the implementation within the IFC mechanics. And of course, we depend upon the IFC 4.3 model, the conceptual model, and this is what we extend. So we've now, and this is what I'm happy to announce, we've now finished everything that was related to the domain taxonomies, and we have this one first version of our global conceptual model for the 3 disciplines ready. We have that ready since the 22nd of December. So that was the goal we set to ourselves. We need to have that ready. And the rest of the year 2022 will have to do with basically everything that relates to the generation of the express code and the documentation, HTML documentation that has to be provided so people understand what the objects are, what the properties are, the way to be to export these entities, and so that they are consistent and so on. So basically, this is going to be our 2022 activity. I was referring to international consensus. Actually, you were too. This is quite of a challenge, of course. I'm very happy that we've put a lot of effort to get to make sure that we have the same understanding of the same concepts, and that we identify the main properties of all those objects, and we agreed upon the definition and what they serve and what they are used for. Besides the, and on that one matter, besides the experts panel I was referring to, we have conducted a series of national industry or national industry association presentations where we shared this, and we needed to have this international consensus that we had built within our team. We had presented it so that we got the national backup of those industry association. And so we've done those exercises on those domains here in these countries. So Italy, Germany, Austria, France, Japan, Norway, New Zealand, Sweden, and somehow in the US. So that took a bit of an effort as well, but that gives us the credibility because all were supporting. Of course, we got a series of feedback and requests for extensions or improvements, clarification, and so on and so on. So we have more than 200 comments that we need to introduce, but we are rather confident on the relevance of what we have defined, we believe. So now a little bit more in detail as far as the scope is concerned. The first thing we decided to make an assessment of is the definition of the different spaces, because we know we are in a very constrained volume, a very constrained environment, and so we needed to define the different spaces that either relate to the result of the excavation itself, the means we used to support the infrastructure and the lining of it. So defining basically the different spaces here. This is a cross-section of a typical tunnel. And the other spaces that needs to be reserved for the systems to implement the systems properly, including the gauge of course, the circulation of the trains or the traffic. We classify that, but these helped us understand what the spatial constraints were and the way we needed to define the entities that needs to describe those spatial constraints. If I look a little bit into the geotechnics aspects of things, there too we spend a lot of time to try to get to a consensus, and I think we have it now, whereby we need to define the geotechnical configuration, the uncertainties that go with it, because these uncertainties generate risks. And classifying the information that way, we ended up with three main types of information, one being factual data, the other one being, by factual data we mean boreholes, laboratory tests, even recollection of information that is encountered during the excavation itself, as far as the underground situation is concerned. Then on the second aspect, everything that relates to the interpretation of that, so interpreted data or interpreted model, which is typically what we would want then to be used by the civil engineer to understand what's the best option to pass through, to align the projects through the geotechnical configuration. And then the third part relates to everything that is related to helping with the dimensioning of the structure itself. So things that would support infinite element analysis and things like that. And this is something that helped us structure the way we wanted to organize the data, and to a large extent this was based on the proposition that was provided by the French Research Center for Tunnel, the Institute, and Florent is here, and I wanted to stress the importance of his input into this game. That really helped to structure, everyone's mind as to how to organize the data, and from there that helped basically document the different objects that are in these three main categories. As far as the structural aspect, we decided basically to organize things around the method used to realize the excavation. So whether this is a TBM-based, so mechanized method, whether this is a more traditional drill and blast excavation method, whether this is related to cut and cover structures, these, of course, are decided upon depending upon the configuration that is encountered, and then from there, of course, the different elements that are put in place to create the structure itself then directly derived from the method. So we started from the method to understand what are the different objects that are actually being built or installed. So the scope covers these three aspects. And concerning the systems themselves, basically everything that is related to, if we start with drainage, it's either the drainage of the supported platform itself or the dewatering of anything that may be encountered as far as soil water, so to speak. Ventilation, of course, lighting, everything that is related to high voltage, low voltage, energy provision, not the traction. Traction is done by the railway team, as you've understood. So we made a split as well, rather clearly in between, the different domains, so that we don't overlap. And everything that's related to fire protection, safety procedures, and things like that. So it's and in that you have a combination of physical objects, but you have as well spaces, which, for example, guarantee a safety procedure. So it's really a mix of, and again, when talking about IFC objects, you would know that an IFC object doesn't need to have a geometry per se. It might be an object that is made of properties. So depending upon the nature of the object that you manipulate, IFC provides a means to document or not document a geometry. So an object is not only a physical object. That's what I meant. When we talked about coherence of concepts, I refer here to discussions we have had earlier on with Jean-Marie Farmegis, for example. I don't know whether he's in the room, but we looked as well as what exists today, for example, when you talk about geotechnics within the OGC mechanics. And OGC, so far, if you look there, we have a sort of a summary of the gaps or the lack of concepts that are today the fact within the OGC mechanics, and the ones that, of course, we need to add, to complete within the IFC mechanics. That's the two columns here. But what we came up with is that this logical common model here is going to be implemented within IFC and is going to be implemented within OGC. And that was there was the objective of today's announcement that was made, a joint announcement between OGC and BSI around the fact that we aim at having this and maintain this common model, and then everyone will deal with it with its own way of implementing, giving the opportunity to any software vendor to use whatever he feels more comfortable with. But at the end of the day, our mission here is to help the ones on the civil engineering side who need to understand what the geotechnical configurations are. And OGC does its own stuff and extend its own geology, hydrogeology, geotechnical concepts. So that part is to start this year, where we have, of course, started. The OGC part is to start this year, 2022, and we started last year, 2021. One reference to the fact that we talk about BIM for infrastructure, and of course, we benefit from all the work that has been done around the definition of alignments, the definition of DTMs, and the work that the IFC rail team, the IFC road team have provided as well in order to extend to solidify the definition of alignments and the georeferencing. The georeferencing means that as part of an IFC exchange, you can define the geoid, you can define the projection system, you can define the coordinate system. So there is important to understand is that there is no difference in the way IFC for infra deals with georeferencing versus the way GIS deals with georeferencing. This is exactly the same way, and this is ISO documented. So we really share this. So if you see, conversations around GIS refers information globally, BIM deals with local objects, that's not true. BIM for infrastructure deals with georeference objects. We have linear infrastructures. They know exactly what projection system is, what distortion is, and so on and so on. And we document this when we exchange an information package of a particular project. So it's important that we have this very clear in mind. And again, all this is ISO documented. I was referring to alignments. In a tunnel project or underground project, you would typically have an as-designed alignment, you would have an as-built alignment, and you have the either roadway or railway alignment, connected or not connected, related or not related. But it's important that within the project we differentiate the different alignments that we manipulate. We propose as well an extension in terms of dealing with the transition in between cross sections. Today there is a limitation that only allows for a linear transition in between cross sections, and we know that both on bridges as well as on tunnels we have non-linear transitions, whereby we have to modelize properly an enlargement of a tunnel, we have to modelize properly the connection with a bypass, and all those particular situations have to be described properly. And it's not that easy, but we've the kind of proposition we have with so-called guiding curves, we can extend this geometrical definition to reflect properly what the design has envisioned. Likewise, in terms of geometries extensions, and again, IFC is not only about geometries, by far not, we have this proposition for voxel models, which basically are 3D grids, which can carry within every single cell different information, different values of different parameters, and can be combined. So you can combine different parameters of different criteria within this model, a bit like Rie was presenting earlier on, a bit earlier on this morning with this idea of co-grigging. You would carry that information over to the civil engineer so he understands exactly what's the situation along the alignment that has been pre-envisioned. It's rather a lean mean of conducting and transferring information. And again, it carries the result of what has been defined or calculated within a geotechnical modeler, right? So it's really this matter of exchanging information properly. And we know that today this is a bit of a nightmare. People use Excel files and things like that, and this is complicated. Just as far as the release process itself, of course, we follow what the BSI process is about, and we are somewhere in the middle of these two boxes here, where we continue building the consensus when we are, and this consensus is yet not only on domain matters, but it's as well on of IFC implementation matters. We are lucky enough, I didn't mention that, but we are lucky enough to have software vendors as part of our stakeholders today, including the ones who release Leapfrog, for example, Plaxis, the Vianova team in Norway as well, ex-Vianova team. So people who have a view of the implementation given the capacity of their existing software packages, because they deal with underground projects today with their solutions. The taxonomy I was referring to basically is a set of Excel sheets, and this is something that we've made public, if I'm not mistaken, on the three domains I was referring to. Most of our efforts over the past 9 months have been around defining, extending the IFC 4.3 models through a UML modelization to have it clear where we want to branch ourselves and our different objects, knowing that two things, we don't want to, we want to reuse as much as we can what exists, especially when it comes to systems, but we know that there are specifics for those systems when they are installed in a tunnel, number one. And number two, we based our definitions upon this capacity of an object to carry basically 4 main characteristics. Everything that relates to georeferencing, geometries, properties, and relations. Relations being an object can be a part of a functional system. It has to know that it serves a particular ventilation capacity, for example. Then those relations can be set so that the objects logically are linked with each other. And this is something that the IFC mechanics allows. class 4. A little more in terms of the modeling tools we use. There are existing modeling guidelines that we apply. This has been used by the other teams as well. This is a very neat meet to make sure that we are consistent all across our teams, and that we as well help facilitate the understanding of the experts, the domain experts, of what we do in terms of implementation. We use Enterprise Architect for that one matter. We have the baseline I was referring to. This is where we based, what you see here is basically the extensions that we are providing. The project, one of our projects is in there, and then our own project extensions are at the bottom. And I'm not going to be going through, but it's a very significant set of new objects and new properties, of course. Predefined types where need be, and so on and so on. Properties, mandatory, optional, what values, and so on and so on. When preparing the candidate standards, there is of course the documentation that comes with it. And if you look through, or if you scroll through the IFC website, you'll find a documentation that is of that kind, and this is typically what we add in a bit of an automated way from the UML modelization. That's the neat part of it as well. Is that once the UML modelization is done, this part of the documentation can be generated somehow automatically, and that's very nice as well. Of course, and in line with what has been presented by the IFC railway team, we are preparing an effort around supporting the software developers to implement those capacities within their package. So it's basically import-export capacities, and to that end, we are preparing from an industry expert's perspective. We are preparing exchange scenarios with data sets for the software vendors to test their functions against. And maybe something I could stress as well is the fact that where we put a little bit of a pressure, of course, on the software vendors to realize this implementation, because this is going to be helping them. I mean, clearly, if you are a software vendor today, you deal with IFC, export, import, which are not that well structured in that one domain. So with this, we help them, we simplify their work, and that's the same for railway or railways. We simplify their work. At the same time, the ones who own infrastructures, when they place tenders, they really have started, and that you probably know of this. The Scandinavian authorities have now requested that for every infrastructure project, documentation be provided through IFC 4.3. This might take time, but the point there is that this is another way, of course, to pressure software vendors, but it's logical expectations on behalf of infrastructure owners to get information structured properly through tenders, and of course through the deliverables of the tenders. So the Scandinavian Ministry of Transportation have done this. Sweden, Finland, Norway, Denmark, the US, the Department of Transportation, the DOTs in the US, they are preparing something very similar, specifically on bridges to start with, and I think this is a key move forward, of course. And I'll finish with this one slide, just on time. By announcing, as I was saying a little bit earlier, that we've finished this rather significant conceptual model for the 3 disciplines: geotechnics, excavation, support lining, and systems. We've finished that. We've documented that, and this is the objective of a report. We have not circulated the report yet, but it lists basically all those objects, the characteristics associated, and their definitions, especially with these 3 main information. So that was quite of an effort. I hope I give you a sense of the amount of energy that we put into this project. It's a rather short, in BSI terms, it's a rather steady pace at which we move this project forward. And frankly, we have a team that is extremely motivated, extremely experienced. And the final goal at the end is that we bring those three disciplines to work together in a much easier way. We know that this is difficult between geotechnicians, civil engineers. We know this is difficult between civil engineers and system engineers. And we really have the ambition with this to simplify and make sure that everyone understands better each other's expectations and value at the same time. It's just valuing what the others do. So I try to, I'm conveying a positive message here. Thank you.
Thank you, Michel. We might have time for a short question, either from the room or from the online world. Frédéric, do you see anything?
There is nothing on my side in the chat, but guess what? I have a question about dictionaries.
Please.
Yeah, we have seen the airport presentation before yours, Michel, and we've been discussing about this proof of concept and enriching the model by adding semantics from the dictionary. What do you think about that? Do you think it can be possible to have the same thing or same way of thinking in the tunnel group?
Yes, absolutely, and I think that with your help, Frédéric, we've started to initiate this. We are going to be having, of course, a building smart tunneling dictionary. And by the way, I think that this building smart data dictionary, this BSDD offering, is probably something that we should stress more because it has a great deal of value. You were referring to what you do in the airport room, but for example, the city of Amsterdam, they have created their own data dictionary, which is hosted through this proposition. For us, I forgot to mention this. Thanks, sorry, but I forgot to mention this. But we know, for example, that in different countries there are national quote dictionaries or national classifications. For example, in Germany, the German DARP team has put a lot of effort in creating a classification that they apply. But the classification comes as a complement to an object model. And you linked the two. You make a link between a classification and an object model. And so this is basically what we do, comes very much in supporting the classification efforts that national industries have done. Or, for example, an infrastructure owner like SNCF, they would have their own classification, and the classification would refer then to the relevant objects into the object model. And frankly, I believe that this is something that the BSI should stress more, because it really leverages what has been done, providing a mean to create object models that are rich against those classifications.
Thank you.
Thank you, Michel.
Well, I think it's time. Everyone is listening for the dinner.
Lunch?
Yeah, lunch.
Dinner would be...
Yeah.
Okay, lunch. Then lunchtime then.
All right, then. It's time to conclude this session and to thank all the presenters. Thank you, Frédéric, for co-chairing this session. And that was it for our presentations. Have a good lunch. Bye.
Bye.